So far we have talked about polygons, we've talked about quadrilaterals, we've talked about parallelograms. Now we're going to dive into some very specific parallelograms. So these notes come from section 6.4 and 6.5 in the text. So let's just review what types of quadrilaterals we have. You can have any kind of generic quadrilateral, but these are specific quadrilateral families, very special quadrilaterals. So the first kind we have are parallelograms. That's what you were just quizzed over today. Parallelograms being opposite sides are parallel to each other. And of course we know they have other properties as well. We also have trapezoids in the quadrilateral family. That is a specific type of quadrilateral where you have only one pair of parallel sides. And then we have kites. And kites have special properties also that we will talk about more later on this week. And of course, in the trapezoid family, we have some specific kinds of trapezoids, but we'll talk about that once we get into trapezoids. So inside of our parallelogram family, we know that our properties of parallelograms that we just studied, both pairs of opposite sides are parallel. We know that both pairs of opposite sides are congruent. We know the diagonals bisect. We know opposite angles are congruent. And then we know consecutive angles are supplementary. So let's review the types of parallelograms we can have. We can have a rhombus, a rectangle. Now a rhombus and a rectangle are separate, two different types of parallelograms. But when we join together a rhombus and a rectangle, we get a square. And so what we're going to do in these notes are talk about the specific properties of each of these. Okay, properties of a rectangle. Well, first of all, let's talk about the definition of a rectangle. A rectangle is a quadrilateral with 4 right angles. So we know that it's equiangular. If all 4 angles are right, they are congruent to each other. Thus, it is an equiangular quadrilateral. It is going to have all of those properties that we've already talked about of a parallelogram, plus another property. When we look specifically at a rectangle, the diagonals are going to be congruent to each other. If you recall, when we used our sticks and constructed the various types of parallelograms, when we made a parallelogram, the diagonals were not the same. If you recall, one of the sticks was red and one of the sticks was blue, thus meaning that they were not the same. If we were to have changed that parallelogram into a rectangle, we would have seen that they're going to be the same size. And we'll use the sticks a little more in class and look at some of these properties again. So the diagonals on a rectangle are going to be congruent to each other. So again, that is a special property only of a rectangle. Properties of a rhombus. Let's talk about what a rhombus is. A rhombus is a quadrilateral with 4 congruent sides. So it is equilateral. A rhombus is going to have all of the properties of a parallelogram, plus it's going to have 2 additional properties. The diagonals are going to be perpendicular to each other. So here we have a rhombus. All 4 sides are the same. When I construct the diagonals, it's going to form a right angle right here. The diagonals also bisect opposite angles. So I know that opposite angles are congruent. So really this red and blue are all going to be the same. And over here the green and purple are going to be the same. So if this were 60, this would be 60, this would be 60, this would be 60. And let's say this is 30, this is 30, this is 30, this is 30. So we're going to have 4 pairs of congruent angles. I'm sorry, we're going to have 4 angles congruent to each other and then 4 additional angles congruent to each other. Okay, so let's talk about a square. Now, a square is a regular polygon. That means it's equiangular and equilateral. It is taking a rhombus and a rectangle and putting it together to form a square. Now, square is going to have all of the properties of a parallelogram. It's going to have all of the properties of a rectangle, meaning its diagonals are going to be congruent to each other. And it's going to have all of the properties of a rhombus. So it's also going to have the diagonals bisecting opposite angles and the diagonals perpendicular to each other. So things to look for in certain problems, and this isn't going to cover everything, but this is just a couple of big ideas of what you're going to look for when we're doing some problems. When you have a rhombus, if the diagonals meet at a right angle, you're going to have 4 right triangles. So this red one's a right triangle, yellow, the blue one, and the aqua blue colored. All 4 of these angles right here, 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 and here are all going to be right angles, meaning all of the sides of the rhombus are each going to be a hypotenuse on each of these triangles. So what formula are we used to using when we have right triangles? Well, you're going to be using the Pythagorean theorem to find certain pieces of your triangle. And on a rectangle, we're going to have something sort of similar. When you have a rectangle and you make the diagonal, you're going to have 2 right triangles. So your right angles are going to be here and here, and your hypotenuse is actually going to be the diagonal. So again, we're going to use Pythagorean theorem. Now, both of these types of problems will be found in squares because a square is a rectangle and a rhombus. So again, this is a general overview. Tomorrow in class, we will practice some problems with all of these and see exactly how we're going to use each of these properties.